Thank you for coming to my session today. I'd like to start off with just kind of get a feel for the room. How many people here have used Git before? So most of us, which is understandable given that the talk is about Git BISECT. I want to start with a bit of a story of how I got to my talk title and my talk. I started by thinking, well, what do I want to talk about? I knew I wanted to talk about Git. And I thought, well, we'll do wrangling Git's not at all existent user experience to make it do useful things. Because if we've used Git, we kind of know that it doesn't have a user experience that's very good. It's complicated. You have to know exactly what incantation to give. But this is a great talk title. And then I thought a bit more about it and realized I could do an entire summit or 4 on this. So then I thought, well, let's go a little bit further. Let's narrow it down a little bit. Came up with a study of Git's commands and why they're so difficult to use. But again, there's 140 or so commands. Could do a whole summit on that. So it's not specific enough for a 45-minute session. So I thought, well, what if I was Git? What might I say? Usability? What's that? Because, again, Git's not very usable. But then I got to thinking, and I have actually used Git BISECT before to find an error, and that's where I kind of came up with the talk today about using Git BISECT to track down hard-to-find issues. And before I get started on that, just a little bit about myself, a little bit about my background. My name is Cory Knox. I am a software developer for Chocolatey Software. I do computer things, and sometimes they work. And that has been my professional life for the last 15 or so years. Prior to starting at Chocolatey, I spent 10 years working for a tire retailer in Canada doing end-user computing support using PowerShell for the entire life cycle of computers, from imaging them in SCCM to installing the software, and ultimately the recycling at the end. We would send them off to our location would send them to a recycler. That recycler would ensure that the hard drive was wiped, and then they'd give us a list of, here's everything that you sent us. And using PowerShell, I'd take that list, I'd remove the computer from Active Directory, from SCCM, kind of do everything to clean it up. And outside of work, I like to do interesting things in PowerShell and in C#, as well as contribute to open source products or projects in particular, usually in languages that I haven't used extensively. In particular, for instance, we use Kitchen Pester for some of our testing at Chocolatey, and I was able to contribute a feature to it that allows us to better keep track of the tests that are being run and whatnot. And so today, I'm going to talk about Git BISECT, just a bit of an outline. I'm going to go over what kind of a brief description of what Git is, what makes it useful for us, and in particular for Git BISECT. Then we'll cover what Git BISECT is, what makes it efficient, and then we're going to get into the kind of the nuts and bolts of when not to use Git BISECT. Because when all you have is a hammer, we all know the saying, everything looks like a nail. When all you have is Git BISECT, everything looks like a usability issue. Or at least, no, sorry, that's Git. Git BISECT is different. But then once we cover when not to, I'll give you an example of when to use it, as well as we'll go over how to use it, because knowing when to use it is only half the battle. If you don't know actually how to use it, that doesn't really help. So what is Git? So we've all used Git before. We know how to use it as a source control. It's distributed source control. If you come from the before Git days of Subversion and CVS and Visual Source Safe, you'll know that those had a central server you had to communicate with, and if you weren't online, you couldn't check out code, and only one person could check out something at a time. So they came up with these distributed source control where I get a copy, you get a copy, and we're just like Oprah doling out copies of our source repository. And so it's distributed, so we all have a copy of it, but we all also know of GitHub and GitLab. And those, although they're front ends to Git, they're not actually Git. They just help us work better with Git. But the big part about Git that actually really helps us, especially when we get into using Git BISECT, is that it is a directed acyclical graph. And if, like me, you may or may not have been paying attention during algorithms course, or didn't take algorithms course, a directed acyclical graph is a big fancy computer science term for a data structure that has, it's a graph, so it has nodes and edges, and the edges connect the nodes together. The directed part of it is that those edges are basically arrows pointing from one to another. And so you'll have, in Git, we call them commits usually. You'll have a commit as the node part of the graph, and commit A will point to commit B, will point to commit C, and so on down the road. And it's acyclical in nature in the fact that you can get to commit D, and commit D cannot point back to commit A, because that would complete a cycle, and that would break it, and computer science tells us we can't do that. So that's what just kind of the overview of Git is, and how it comes in with Git BISECT is that Git BISECT, it's a method for searching between two commits. Say you have a version of your software, say take Chocolatey 0.10.15 that you released in 2019, and then you release version 0.11.0 in 2021. And you want to search between those two releases to find where an issue is. You could go the way that I used to go, start off at 0.10.15 and check it out, test it. That is not a problem, so you step ahead one commit and test it out again. And you keep doing that 270 times. That's not really the best way to do it. So Git BISECT gives us that so we can search between the two commits. We use it typically when there's a behavior change that's been introduced. In particular, we will use it when we don't know exactly where an issue is occurring. And it's effectively a binary search, which, harkening back to algorithms course, the binary search is a method of searching between two points on in a sorted data structure list of types that you basically go to the middle and you check if it's either on one side, it'll be on one side or the other, and you just divide and conquer through it. And I wasn't supposed to show that one yet. So I mentioned it's used for searching between two commits, and in particular for finding behavior changes when they're introduced. And now, if we were following the ideal Git history and doing things the way that we're told we need to do them, everything would be in a straight line. You have one commit onto the next. Your commit messages are all saying what the issue is, and it's easy. You just have a straight line. In particular, when you're trying to find an issue, you'll have, like this one right here, where you say insert bug in software. Well, we don't need to go searching for commits because we put it right in the commit message like we're told to. Unfortunately, or maybe fortunately, we don't live in the ideal Git history world. We all live in the real world, where we have real-world repositories that look like this, where if you're from my generation, or I don't know. I used to play a game called Guitar Hero, and it looked an awful lot like this. Except that they weren't Git commits. They were notes that you were supposed to play, and you could pretend that you were amazing at playing guitar, even though you could kick it and it would sound better than you playing it. And these are, as I said, these are real world repositories. On the left, I actually can't remember exactly which one I pulled this from. I think it might have been, the more I think about it, I can't even remember. But the second one here, this one is taken from the Test Kitchen repository that we use for testing Chocolatey. And what you'll notice is that there's these little branches that come out, and my head is on a lot of them because I do a lot of writing of those tests. But we branch off in various directions, and then the one on the right is from Chocolatey, Choco, and similar. We have a lot of branches. In particular, in that one, we have 4 or 5 or 6 active branches, which makes it particularly fun when you're trying to track down a bug. Or like this one that's more in the middle. This one, although it's taken from a real repository, it's not actually real code. It was just me writing stuff to try and make a graph that looks really, really hard to follow, because it talks about tracking down things, especially when it's hard to follow. But these are like the way that we'll see them. We branch out, we do a few things, then maybe something comes up and we need to go back to the original branch and branch off again, or branch off in the middle of a branch. And so tracking from, like on this one, from the bottom one up to here, it's hard to tell, well, do I go up here first or do I actually go to this one? And Git helps us with that, in that we don't have to worry about what it all looks like there, because we'll just give it commands and it will step through it for us. But ultimately what makes Git BISECT efficient is that, as I said earlier, it uses a binary search. It means it splits the search space in half. So in the case of Chocolatey 0.10.15 to Chocolatey 0.11.0, you have 270 commits. You split it in the middle, you get to commit 135, and then you determine whether your behavior exists or not. If it exists, you discard everything else from the side where it exists, and then you eliminate that half of the search space, and you repeat the process. Now from 135, you go down to 62. And then from 62, you would go to 31, and the math says eventually you get to 0. Don't ask me to do such simple math in front of everyone. So that's like, the binary search makes it really efficient, and you don't have to worry about the branching and the ordering of the commits that we saw. Like, it does it for you. In particular, if you weren't using Git BISECT and trying to do that manually, you then very quickly run into the, well, this branched off, do I go up that branch or do I go to the next commit that happens to be in the middle of the branch somewhere? So, as I said, we want to cover when not to use it. And I'll give you actually an example of when you might not want to use it. Is first, you can't reliably reproduce the issue, but that's just troubleshooting 101. I don't know about you, but I've gotten tickets before that said, this issue happens, and then when I contact them, they can't reproduce the issue. And therefore, we can't fix the issue. If you know exactly what line of code is causing the issue, then you probably don't need to use Git BISECT, which is kind of ironic being at PowerShell Summit and talking about this, because I don't know about you, but recently when I've run code that had errors, PowerShell was very helpful. And as the PowerShell team was telling us during the State of the Shell, that with the enhanced error views and just what they're adding for the error views, it tells you exactly where the issue is. It says in file X on line Y, which makes it really easy to find where your issue is. Now, that being said, that's if you're looking for an actual error. Or the other place where it would be in, actually, sorry, I'm getting ahead of myself there. So the other as well, if you know exactly when the behavior was introduced. Recently with Chocolatey, we introduced hooks. And these allow you to run various scripts before a package installs or after it installs, or in various scenarios. And they're separate from the packages themselves. And so we introduced that hooks behavior, and then we had a report of a scenario where someone somehow got on Windows 10 and got PowerShell 2 enabled, and Chocolatey was calling into PowerShell 2. And this comes into the whole not reliably reproduce the issue, because we weren't able to get Windows 10 to ever behave like that, but they did. But in particular, one of the things about Chocolatey is at the moment we support PowerShell 2. And so that would identified an issue for us for the scenarios where someone is in a case where they have PowerShell 2. And we knew it was with the hooks, and I was able to know exactly when the behavior was introduced. And in particular, we only had a few commits. And as I said, we're reasonably sure when it was introduced. We had the version before we introduced hooks, and then the version where we introduced hooks. And in particular, for hooks themselves, there was only 3 or 4 commits. So we really didn't need to bisect them and try and track down the issue. And so, but now that we know when not to use it, we want to talk about when to use it, because otherwise, why else would we be able to talk about when to use it? And when you can reliably reproduce the issue, but again, that's troubleshooting 101. If you can reliably reproduce the issue, then you can start looking at ways to, or figuring out how to fix it and where you might have introduced it. But if you don't have an error message that tells you exactly where the issue is, for instance, in PowerShell 2, when you got an error, you just got an error. It said, hey, there was an error. It doesn't tell you what file it came from. It doesn't tell you what line it was on. It doesn't even tell you what command it was trying to run. It just says the value on the right side of the hyphen can't be something. I can't remember the error. And this is actually the scenario where I use this is between 0.10.15 of Chocolatey and 0.11.0 of Chocolatey. We introduced the bug when run with PowerShell 2 that you got an error. But we didn't know when the behavior was introduced. Like, we knew it was somewhere in that 2-year period. And in particular, we had a lot of changes to look through. I said there was 270 commits to look through. Not really that great to try and track down. So we've covered when not to use it, when to use it, but not yet how to use it. And I'm going to cover kind of, there's 2 ways to use it. You can use it manually, which is probably the best place to start. And then you can also use it automatically, and it will just kind of do everything for you, which is amazing, but also terrifying, in particular because it's Git. So to use it manually, you start off by issuing the git bisect start command. And then it will ask you for the good commit and the bad commit. And you'll say git commit, or git bisect good commit ish, which I see it all the time in the Git documentation, and I take it to mean a commit or something that points to a commit. Could be a branch, could be a tag, just eventually something that gets to the commit itself. And then you'll give it the bad commit, and now that it's at the, now it'll take you to the first commit between them, in which case you'll perform whatever action you need to perform to determine if your behavior exists at that commit, and then you'll tell it if the behavior does not exist, you'll say get bisect good, and if it does exist, you'll say get bisect bad, and you just keep repeating that until finally Git will spit out at the end, say, okay, this is the commit that introduced the behavior that you're trying to isolate, and it'll give you the commit and the commit message. And then from there, because you're in the repository, you can run any sort of Git commands you want or any other things on your repository to try and isolate it. In particular, you can do a Git show, which will show you the actual changes, as well as the files, and tell you exactly which parts of it changed. And then once you're done, you'll say git bisect reset, and that will just take you right back to wherever you started from. Usually you would start from, like you'll probably be on the head of whatever your default branch is. And then you run through all the commands, and instead of being, in the case of what we'll look at today, instead of being 1,000 commits behind, it'll just bring you back up to date. But we're PowerShell users. We like to automate things. And so we'll cover off how to do it automatically. The first step, as we know to all automation, is that you need to know how to do something manually before you can automate it. And we'll start off the same way by issuing the git bisect start, good and bad commands. And this, again, is just setting us up to the point where Git knows exactly what we're looking to search between. And then now where's where the command changes. We say git bisect run, and we give it a command, either the name of a script or an executable or something that will run, and it will determine if the behavior exists for us. And then if it does exist, it will report back to Git whether it exists or not, and Git will just keep running that until it gets to the end, and now we're at the commit that introduced the behavior. Much quicker, way easier than doing it manually, but there are a few caveats. Actually, sorry, we also have to git reset again to get back to the beginning. But that's quick and easy, but the caveats are that we need to know when to use it automatically. In particular, we need to be able to detect the behavior screen or behavior change with a script or an executable, because otherwise it doesn't work. Now that detection could be as simple as, say you're building a website and your background color somehow changed to purple, and you don't know when it changed to purple. You can have it do everything to spin up whatever environment you need and launch your browser and then just say, okay, is it purple? And you can tell your script yes or no, and it can do everything for you that way. It must exit with 1 if the behavior exists, and 0 if it doesn't. If we don't, then git bisect doesn't know, and as I found out when testing and demoing this, if you exit with 1 the entire time, you get to entirely the wrong commit. And then it's also good to use it when reproduction steps are cumbersome. In the case of the chocolatey bug that I was trying to track down, at that time I needed to run it, I needed to build chocolatey, copy that over to a Windows 7 system that had PowerShell 2. Then I had to try and install it to figure out whether the issue was there or not. And then I had to revert my VM because I had changed it, and then keep repeating the process. And if there are lots of potential commits, like with the 270 commits, there's only 7 that you need to step through. So it's not too bad, but like the more you get, the more you're going to have to run it. And it's really easy to start typing in the wrong git bisect good or git bisect bad. And so that's kind of mostly the end of the slides. I'm going to go to a demo and actually show you the git bisect in action. Both the git bisect, doing it manually and doing it automatically. It's not quite centered on the projector, but nothing on the outskirts actually really matters. So I'll show you on the left here I have just Windows PowerShell that comes on Windows 10, 5.1. And on the right I have that same PowerShell just running in a PowerShell 2 mode, because, as I said, the issue we saw only happens when you're in PowerShell 2. So we start off and run our git bisect start command, and I'm using PoshGit on the to help with my prompt, just because it lets you know exactly what's going on and whatnot. And then so we've started it. We do our git bisect good. We're going to tell it that that's 0, 10, 15, and git bisect bad. Apologies, I'm not used to this keyboard. I have a ErgoDocs that I'm normally using. So my terminal might get shouty later when I go to hit hyphen and hit caps lock instead. So we've started our git bisect, and now it helpfully tells us how many revisions that it has left to step through, and roughly how many more steps it thinks it'll take. And now we need to test and see if we can reproduce the issue. Helpfully, I've put this into a script, so I can just run this manual.ps1, which will, I should actually, I don't have a home button. So this script really just takes the Chocolatey installer module, and I realize you might not be able to see all of it, but it removes the module, and then it tries to import the module. And because it's on PowerShell 2, like this is the issue I was running into when looking at it, is that all I knew was that we were trying to import this module, and it was failing on PowerShell 2. And so that's what we've done there, and we run git bisect good, because the behavior does not exist. So now we'll run the command again, and we see that, again, we have a good commit. So I can tell it git bisect good, and we'll run it again, and we'll see that we get an error. And this is one of those very helpful errors that I was telling you about that PowerShell 2 had, is you must provide a value expression on the right-hand side of the hyphen operator, which is really helpful because there's a lot of hyphens, and I searched through all of the PowerShell code in the Chocolatey repository, and the only time that the hyphen occurred by itself was, actually, if I think about it, I don't think it did at all, because we don't really do much math in the PowerShell files. So this didn't help us track down the error at all, because there is no instance where we have the hyphen and then a space. And so in this case, instead of git bisect good, we're going to do a git bisect bad. And then we're going to run our command again. And we'll note that it errored again. So we're going to do a git bisect bad. And those observant might notice what I didn't notice at the time is that we got 2 errors before and now we only got 1, which will feed into a little bit later. But so the error is still there. So we're still doing git bisect bad. We've got 3 revisions left, and there's 2 more steps, which tells me that we're getting pretty close because we were at 270 revisions at the beginning, and now we're at 3. And so the error didn't come up, so we do a git bisect good instead of bad, and then run it again. The error occurs, so that one is again bad. And then this is git bisect expects that this is the last one, so we run it again. It still happens. So now we do a git bisect bad, and it gives us our commit. And we can scroll up through the commit, and we can see the commit hash. The author of it is Gary, and if you've ever been part of our streams or just part of our discussions, you'll know we don't let Gary write PowerShell, and this could very well be a reason why. And so this, and you'll notice that this was also introduced in May 2021. And when I was trying to track down this issue, it was, I believe, October or November 2021. So some months later. But it also, this tells us, as Git normally does, it tells us what file it is, and we can do a git show. Will show it all again, but then it will give us the diff at the bottom, and we can look through and see what part of it changed, which is helpful. But in this case, the hardest part to figure out is if you're not familiar with PowerShell 2 versus PowerShell 3. In PowerShell 3, this not in is valid, which means all of our testing that we did on Windows 10 or later, everything worked fine because we're all running PowerShell 3 and newer. But not in was introduced in PowerShell 3. Dash contains was introduced in PowerShell 2. In particular, dash contains and not contains. So that tells us exactly what the issue is. We can go through and we can fix that file and then be good. After, of course, we do our git bisect reset. Now, when I was fixing this at the time, I found that. I went and fixed it and changed it to a dash not contains and flipped the operators around and thought, well, this is great. And I put up a PR and then I built it and I copied it over to my Windows 7 system, and it failed with the same error. Which is, as I mentioned earlier, if you notice, there was the 2 errors on the right-hand side. And I thought, I don't want to go through and look for it all over again. And if we're being honest, all I did was actually just search across, because I knew it was dash not in now, so I just searched for dash not in. But if I didn't know, if we pretend that I didn't know, we can write a script that does all the stuff that I did on the right, because when I was first figuring it out, I didn't know necessarily that I could test it in PowerShell 2 because I didn't know exactly where the issue was. But once I found the issue, I was able to test it like I did here on the right side. And what I'm going to do is get rid of that PowerShell altogether, or at least minimize it. And so to do it automatically, I wrote a script, which, if I can type, and this one is very similar to the manual one, but it takes in a parameter that says how many errors occurred. We remove the module silently. Then we clear the error variable, because if we don't, and we try to remove a module that doesn't exist, we'll get an error. And then we import it, and we say if the number of errors at the end does not equal the number of errors that we expected, or sorry, is greater than the number of errors we expected, then we'll exit with 1. And so we would start our get bisect start, get bisect good 0, 10, 15, and get bisect 0, 11, 0. Whoops, bad. And then we do the, as I said, the if I recall what I said, the command is get bisect run, and we can't just give it a PowerShell file directly because Git unfortunately doesn't know what PowerShell is. On I believe on macOS you can if you have a shebang line at the beginning of it, but then you get into the whole how it works and whatnot. But in this case, and especially in this case, we can't do that because we don't have PowerShell 2 on there. But if we spell PowerShell properly, and we give it a -version2, and then we tell it the file we want to run is our C vagrant bisect, and we give it our number of errors, and we tell it that we want to find, so we've already found where the number of errors is greater than 0, so we want to find any where the number is greater than 1. And we're going to run that, and we're going to see it just runs it and steps through the commits. And then we see there was our 2, and then it's back to the 1, going through, and finally it takes us to this one, where again, it looks. I think the previous one was also about changing the environment. No. This is what I did last time. Okay, so we got to start over. But it's automated, so at least that's good. And I said, this is what I did last time when I was testing it. Oh, that wasn't the one. Because if we recall the script that I wrote, it asked for a parameter that is num error, and every time I'm typing it out, I've been typing num errors, plural, so the variable actually is still going in as 0. So now if we run it, we get our 2 errors, then we get no errors, 1, 1, and eventually we come out and we see Gary's name again, which, to be fair to Gary, and I should have been fair a bit earlier to Gary in the first one, was that you wouldn't have known that was an issue, like the not in was an issue unless you knew that the PowerShell changed between 2 and 3. And in fairness to Gary on this one, he's the author because he rebased, and I see Rob chuckling because he probably saw Stevie's name at the bottom, and this was Stevie's commit. And now, also to be fair to Stevie, Rain told Stevie to change his commit in this PR. And this one, if we do a git show, I will see that it was the same thing. We used not in down here. And in particular, the reason for using the not in was just for efficiency, because I think, if I recall in the original PR, Stevie had just added on to that if that said installer type lower not equal MSI and not equal exe, and just throw in and not equal MSP on the end. And looking at that, Rain said what any of us would have said, well, let's make it clearer and more efficient and just use something built into the language. So that was that one. And git bisect reset. And so that's kind of the how to use it, or a demo of how to use it. And I think, if I recall, that was kind of the bulk of the presentation. Are there any questions? Rob. So the question was when I used the command to label the bad commit, I said git bad or git bisect bad 0.11.0, and how was I able to use that 0.11.0 part? And that gets into the commit-ish part of Git, is that we have a tag on the repository for when we put out a release. So we have a tag that is 0.11.0. And so when I tell Git to use that one, it was able to find that tag that points over to the commit. And that's just kind of how it figured out what I meant. So if tags were not being used, you could use the full commit hash, or you could use branch names. So if it was on say release a 0.11.0 branch, you could just issue the git bisect bad release 0.11.0, and Git just does its magic and figures out what commit you referred to. The question is, if I ever run into a scenario before where it seemed like a good use case for git bisect, but ultimately it didn't work out. And I don't think so. Like I've encountered scenarios where initially I might have thought that git bisect was a good use case, but not. Like it wasn't like it wasn't this is obviously a good use case for git bisect, and then going through it, it ends up not being it. Ultimately, when it at the end of the day, when it comes down to using git bisect, even when it's not a good use case, it's still going to be, I guess, it's not harmful to necessarily use it. And in particular, maybe it's a good thing to use it when it's not a good use case, because then you get experience using it. I know I read articles about using git bisect in 2017, 2018, and it wasn't until 2021 where I actually had a use case for it, where I was actually able to use it. Because before I had the use case in front of me, I didn't really know any scenario where I might actually use it. So I will finish with the obligatory please submit session reviews. Thank you very much.